Welcome back to Lil mRNA. We're Fritz and Etta and we love to talk about drugs. For today, we actually prepared the hippie drug LSD. We would like to introduce our unpaid intern in this episode as well, Giovanni, who will introduce this drug, which we definitely did not take when we were at Woodstock. So, drum roll for Giovanni.
Thanks guys. Lysergic acid diethylamide, or colloquially known as acid, is a hallucinogenic drug. Its effects normally include altered thoughts, feelings, and awareness of one's surroundings. And I also heard that some experience visual or auditory hallucinations. So, if you would like to take LSD, for example, for spiritual reasons, the effects would typically begin within half an hour and could last up to 12 hours. So, be careful. Yeah. But how does it work?
LSD acts on a number of different receptors, including serotonin, dopamine, adrenergic, and glutamate receptors. The exact neural pathways are not completely known, nor is how the effect on the serotonergic system causes hallucinations, but serotonin is believed to be the primary cause of it.
Serotonin receptors can actually be found throughout the entire body, but those involved in hallucinations are present mostly in the central nervous system.
Exactly. Serotonin can be seen as the most affected neurotransmitter when looking at LSD. LSD acts as an agonist at the serotonin receptors, as its structure is very similar to that of serotonin on the presynaptic terminal of the ref nuclei. The most important receptor is the 5-HT2A receptor, which is a G-coupled metabotropic receptor and is present in the central nervous system in the ref nuclei, locus coeruleus, and neocortex.
So we should probably discuss first how serotonin signal transmission works before we dive into LSD. Serotonin binds to a metabotropic receptor, e.g. 5-HT2A, where an intracellular second messenger pathway is activated. One of the effects is the opening of a calcium ion channel, which leads to an outflux of calcium ions and an influx of potassium ions, and thus an EPSP. In some areas, though, e.g. the visual cortex and the orbitofrontal cortex, it might have an inhibitory effect. This is due to the receptor causing potassium and chlorine channels to open, which makes the membrane potential even more negative. This is called an IPSP.
This inhibitory effect is actually important in some parts of the brain as it prevents communication between certain parts of the brain and can stop sensory overload. The excitatory effect in other parts is necessary for communication between them to make sense of what we see, hear, smell, taste, and feel.
What is interesting about serotonin and later the effect of LSD is its termination. Serotonergic action is terminated primarily via the uptake of serotonin from the synapse by transporter called SERT on the presynaptic neuron. To stop a signal at the postsynaptic cell, active neurons have to be desensitized. This happens by a beta-arrestin binding to the metabotropic receptor and thus blocking signal. It also promotes the removal and recycling of the receptor from the membrane.
Okay, enough about serotonin. How does LSD affect all this?
Well, LSD, as we talked about before, binds to a 5-HT2A receptor and causes pretty much the same process as serotonin. But there are some very important differences. Firstly, LSD stays bound to the receptor for an exceptionally long time due to a lid that forms around it. This might explain the long duration of an LSD trip. The long binding causes spatial as well as temporal summation in the postsynaptic neuron and thus causes an EPSP, or in certain neurons an IPSP. LSD also exhibits functional selectivity, which means that it activates the signal transduction enzyme phospholipase A2 instead of the enzyme phospholipase C, which is a serotonin-activated enzyme, which is an agonist for many lipid-gated ion channels. Thus, a decrease in the activation of phospholipase C decreases the frequency of both EPSP and IPSP.
So, what effect does this functional selectivity have? Well, the areas of the brain where 5-HT2A is present are connected to nearly all other areas of the brain, and while some inhibitory serotonin receptors prevent communication between certain parts of the brain, excitatory serotonin receptors in other parts of the brain increase communication. The prevention of communication between some parts of the brain are thought to inhibit sense perception to prevent the brain from sensory overload. When LSD now decreases these inhibitory effects between some parts, it might lead to sensory overload and thus hallucinations. There is increased communication between different parts of the brain that are normally not connected, while there is a decrease in communication between parts of the brain that are normally connected.
LSD is also thought to increase glutamate release in the cerebral cortex and therefore excitation in this area, which could lead to hallucinations. LSD also enhances dopamine receptor recognition.
So these excitatory and inhibitory effects either increase or decrease communication between different parts of the brain and thus might cause hallucinations, right?
Yeah, that's what researchers think, but it's not as researched yet as LSD is not thought to be as beneficial in the medical field, and it's really hard for now to understand how hallucinations happen. Although they did find that LSD increases the blood flow to the area of the brain responsible for vision, so that may be a factor involved.
Damn, that's interesting. So what about tolerance? Does one develop tolerance quickly?
Yes, actually, tolerance develops really quickly. Most serotonin receptors are downregulated rather quickly, which means that there's less of them. Thus, spatial summation cannot happen as much, and one might not feel the effect of LSD as much. This means that an EPSP or IPSP is more reliant on being created through temporal summation by an increased intake of LSD.
And this is it for today. Thanks for watching. We hope you learned a lot about LSD and will decide to not take it. If you do and don't feel well, please contact your doctor though. But please also note that we are not encouraging you to take drugs. Okay, thanks. Bye.